My dear students, in this video, I am going to solve some different types of linear programming problems. See, there are some special types of linear programming problems. In that first type is DAT problem. There are three types of linear programming problems. There are DAT problem, transportation problem, and manufacturing problem. Out of these three types of different linear programming problems, first I am going to solve a DAT problem. This problem states that a dietitian wants to mix two types of foods, say type 1 and type 2, two different types of foods a dietitian wants to mix in such a way that in those types of foods, vitamin contains at least 8 units in one category and vitamin B contains at least 10 units per kg. A dietitian wants to mix two types of foods in such a way that the vitamin contents of the mixture contains at least 8 units of vitamin A and 10 units of vitamin B. The two different types of foods are represented by food 1 represented by X variable and food 2 represented by Y variable. Okay, vitamin A, food 1 contains 2 units per kg of vitamin A and 1 unit per kg of vitamin B. Similarly, food 2 contains 1 unit per kg of vitamin A and 2 units per kg of vitamin B. These are the data given. The vitamin A should contain and the mixture at least 8 units per kg and vitamin B contains at least 10 units per kg. The cost of X variable food X is 50 rupees per kg and cost of second food is 70 rupees per kg. First type of food 50 rupees per kg and second type of food is 70 rupees per kg. Using this data, at what rate that the dietitian wishes to minimize the expenditure of the cost of the food. See, our problem is formulate this problem as a linear programming problem to minimize the cost of such mixture. Minimize mixture, cost of minimize mixture we want. See, Z is the cost of the mixture. Total cost of the mixture is considered by Z variable, that is first food contain 50 rupees per kg, therefore X into 50 because X kgs of food 1 is there. Similarly, second food Y kgs contains 70 rupees per kg, therefore 70Y. So Z equal to 50X plus 70Y is the formula linear programming equation. Okay, this is the total cost of the programming equation 50X plus 70Y. In the first case, for food 1, it consists of vitamin A, X. First case 2X plus Y is greater than or equal to 8 because the first quantity is at least 8 units per kg we want. Therefore, this case is 2X, 2 into X plus 1 into Y is greater than or equal to 8. Y greater than or equal to, it means the quantity contains at least 8, minimum 8, maximum whatever it means, greater than or equal to 8, at least 8 units we want. Similarly, the second case, X plus 2Y is greater than or equal to 10. And normally X comma Y, the variables are always non-negative. Using these constraints, we have to formulate the linear programming problem. In the first equation, this is equation 1 and this is equation 2. The first equation, if you put x equal to 0, y equal to 8. First equation, if you put x equal to 0, y is 8. Similarly, if you put y equal to 0, x equal to 2x equal to 8, x equal to 8 by 2, 4. So this is the first line, 2x plus y equal to 8. This is 2x plus y equal to 8. You can plot the graph. X is 0, y is 8. This is the point 0, 8. And second point, x4, y0. This is 4, 0. Now joining these 2 points, we will get the first line. First line of inequality. So this is x0, y 0, 8, and this is 4, 0, and the line is 2x plus y equal to 8. Next, the second line, second inequality, x plus 2y equal to 10. The same manner, if you put x equal to 0 in the equation 2, x equal to 0, y equal to 2y equal to 10, y equal to 5. X is 0, y 5. And y equal to 0, if you substitute y equal to 0, x equal to 10. So x is 0, y 5. This is the point 5. Zero, 5, and another one is 10, 0. This is the point 10, 0. Yes. The equation, this point is 0, 5, and this is 10, 0. Sorry, this is 5. I'm sorry. Seven, I got wrongly. This is ten, 0. Okay, all right. This is 0.5, 0. 0, 5. So for that, yes. This is 10, 0, this is 0, 5, and this point 2, 4. This is the point, x is 2, y equal to 4. See, both the inequalities are greater than or equal to 2x plus y greater than or equal to 8, that means it is unbounded region. It is away from the origin. 2x plus y greater than or equal to 8. 2x plus y greater than or equal to 8 means this is the region. Similarly, x plus 2y is also greater than or equal to 8. This is 2x plus y greater than or equal to 8. X plus 2y is greater than or equal to 10. It's also away from the origin. So, unbounded region. This is unbounded region. Both are away from the origin because both are greater than or equal to, inequality is greater than or equal to implies that the shaded part is away from the origin and also it is unbounded. This is the region. And the line z equal to 50x plus 70y. You can write it as okay. Now the corner points, you consider this point A is 0, 8, B is 2, 4 and C is 10, 0. Corner points and value of Z. Corner point, first point A, 0, 8. Value of Z is, if you substitute x equal to 0, y equal to 8, 7 8s are 56, 560. Second B, 2, 4. X is 2, y is 4. If you put x equal to 2, 2 50s are 100. 4, 280 plus 100, 380. And third point is 10, 0. X is 10, 500, y is 0, 500, 5 into 10, 500. So this is the minimum value. Where should we get the minimum value of A? Is that at the point 2, 4, the minimum value of Z is 380. The cost of the mixture is minimum, that is 380 at the point 2, 4. So 2 kgs of X food 1 and 4 kgs of food 2. If you apply the 2 kgs of food 1 and 4 kgs of food 2, that mixture will give you the minimum value, minimum cost, that is 380. That is the problem. For example, this line you can substitute 550x plus 70y equal to 380. 50x plus 70y equal to 380. This is 5x plus 7y, which is less than, because this is a minimum cost. 5x plus 7y equal to 38. So this is the inequality, gives you the minimum cost of the mixture. If you draw this line, you will get this line. So this is the line, 5x plus 7y is 38. There is no region common, the feasible region. There is no point is common in the feasible region. This line, the solution, observing line, shaded part is this side. Therefore, there is no point is common in the feasible region, bounded region. Therefore, the solution for this problem is, if you mix 2 kgs of food 1 and 4 kgs of food 2, that gives you the minimum cost of the mixture, that is 380. So 2 kgs of food 1 and 4 kgs of food 2. The cost of the mixture is minimum. The cost is minimum, that is rupees 380. That's all about the problem. Okay. So this is the DAT problem. A dietitian wants to mix a minimum cost of a mixture with the data given, that is 380 rupees is the minimum cost. That's all about the problem. Okay. I will stop the video here and we will continue the next type of problem in the next video. Thank you.